As I told, software solution, we are having Peterson's algorithm invented by one person called Peterson, which is also referred as two-process solution. That means what? This algorithm will solve the critical section problem only for two process. If more than one process, this algorithm will not work. Okay, I hope you understand. This algorithm will work only for two process having problem of critical section. Okay, very simple algorithm. So here we are defining two variables, integer, turn. So this turn must have integer value only. Flag will have either true or false. See the size of the flag, it is 2. So total it can accommodate only two values. So that only we are referring it as process, this algorithm meant for only two process. Okay. Okay, so what do you mean by turn, or what the variable turn will hold, whose turn is to enter into the critical section. So as we are having process P1 and the process P2, the variable turn will decide which process will get into the critical section. Suppose turn value equal to 1, integer value, correct? Turn value equal to 1, maybe process P1 will enter into the critical section. That means what? Next turn to enter the critical section is for process P1. So turn value 2 means, so P2 will have its turn as the next process. Okay, P2's turn. Next turn is for process P2. So this will have either two values, only either it is 1 or it is 2. Likewise, flag, what flag will contain? If a process is ready to enter critical section, flag of I will be set to true. For example, flag of P1 will be set to true. So what does it mean if it is true? Now P1 can enter into critical section. If this is true means what? P1 can enter into critical section. When P1 is entering into critical section, what will be the value of turn? It is 2 because P1 is entering critical section. Next turn will be given to P2. Okay. So if this value is false, it doesn't mean, if the value is false, it doesn't mean P2 is in critical section. When we can say P2 is in critical section? Only when flag of P2 is equal to true, then only we can say P2 is in critical section. Okay, if the value of flag of P2 equal to true, now what does it mean? P2 is now entering into critical section, so automatically turn value will become 1. This is algorithm what we are going to discuss here. See here, set first do while. See this statement, do while means as long as there exists some process. Okay, as far as there exists some process waiting for critical section, that is the condition. First statement, flag of I equal to true. See here, carefully listen. I'm using two variables called I and j. Okay, as far as it is considered as two process solution. So only two process I and j. I value may be 1 means P1, j value is 1 means P2. Okay, so it indicates I indicates P1, j indicates P2. That's all, two different process. Okay. Now initially I am setting flag of I equal to true. Okay. So what I told, I equal to P1 and j equal to P2. Some people will say, sir, can I take I equal to P2? Okay. If I equal to P2 means j will be P1. That's all. Okay. So initially I am setting any one process to true. For example, I am making flag of, for your better understanding, instead of I am giving P1. Okay, instead of I am giving P. So this I am making as a true. Flag of P1 is true. So what does it indicate? Now P1 is ready to go into the critical section. Or in other words, only P1 will be allowed to enter into critical section. So initially flag of P1 I am assuming as true. See now here you see turn equal to j. Once I am making it like this, turn equal to j means what? P2. Okay. So before entering into critical section, the flag of P1 is set as true. After setting true only, P1 is entering into critical section. When P1 is entering critical section, by default, automatically, the next turn, who will get? Only P2. So turn value will be assigned as P2. Okay. Now here, carefully listen while flag of J. What is flag of J? Flag of I is true. So flag of J equal to false only. Okay, because it is initialized to false. Before start of the program, it is initialized to false. Okay. While flag of J, okay, flag of J is false, means condition fail, it will come into the next line. Okay. Suppose if a flag of J equal to true, are you able to understand? Flag of J equal to false means immediately it will come out because ampersand condition, it will come out, that is critical section. Who will get the critical section? P1 will get the critical section. After that, what I am doing? Making flag of P1 equal to false because I am coming out of the critical section. So this will become true. Okay, once it is true, P1 will go for remainder section. That's all. P1 will go for remainder section. Okay. Now same algorithm if I am applying for process P2, flag of I equal to P2. So P2 is true. So tan of will be, next tan will be given to P1 while flag of J, while flag of P1 false, it will come out of the loop. Okay. Suppose if a flag of J equal to true, what will happen? Just imagine. Okay. If a flag of I P1 also true, P2 also true means what? And turn equal to J. Listen carefully. Flag of J, for example, flag of P2 equal to true means what? Next process entering into critical section is P2. At the same time, I am assigning turn also J. That is turn also P2. If this condition occurs, that is what I am giving here. Okay, J stands for P2. Flag also P2. Turn also P2 means what? Only P2 will enter into critical section, which is wrong. So that only I am using semicolon here. Okay. So how long this loop will execute? This is a single loop, correct? A semicolon means what? The loop will be repeated until it becomes false. So if both are true, what will happen? P2 cannot enter into critical section or P2 will not be allowed into critical section. That's all. By mistake or some modification, P2 voluntarily setting its value as true because already OS only giving permission for P1 only. But P2 voluntarily it sets its flag to true. Next turn also P2. Now OS will not allow it into critical section. So that semicolon is very, very important in this place. Okay. So as long as this condition is true, the loop will be repeated. When it will come out of the loop, any one condition false. Any one condition become false means what? Either flag will become true or turn will become I. Then only it will come out of the loop. Once it is coming out of the loop, which flag is set to true will be getting the critical section. After coming from critical section, it will become false so that others can enter into the critical section.